10-6, day 2, circles and arcs. Circumference of a circle. Hopefully you can recall that the circumference of the circle is the distance around the circle. And then again, hopefully these two formulas look familiar to you. Those are the two different forms of the circumference formula. Now, I know this isn't on your note sheet, but I do always get asked this question, or I shouldn't say always, but quite often. What is pi? Pi is actually a specific ratio within a circle. It's always the circumference compared to the diameter. And actually that is found really easily by solving for pi in the first circumference formula. If you divide both sides by the diameter, you'll see that circumference divided by diameter is equal to pi. And that relationship is true for all circles. So now concentric circles, you actually saw this on one of your homework problems from day 1. These are circles that are in the same plane and have the same center point. So concentric circles, a lot of times people think of targets. You put a circle in the middle, and then outside of that you put evenly spaced rings typically. Each of those rings is actually just the visible part of another circle that would be concentric with that innermost circle. So number 3, we have this car that has a turning radius of 16.1 feet. We know the distance between the two front tires is 4.7 feet. And in completing one full turning circle, how much farther does the outer tire travel than the inner tire? So first thing we'd want to do is get ourselves maybe a diagram for this. So this is a problem that deals with concentric circles. The path of the inner tire and the path of the outer tire when you drive in one full circle would be concentric circles with each other. Now that turning radius of 16.1 feet, when you talk about turning radius of a car, that is the distance from the center of that circular turn to the outside tire. So that's why I have the larger radius here labeled as 16.1 feet, and then I also have labeled the distance between the two tires. So if we want to find the distance the outside tire travels, we need to realize we're using circumference. And in this case, I'm going to start with the circumference equals 2 pi r formula since I'm given the radius. So I plug that in. And now I'm going to keep this in terms of pi for right now because I don't want to round until the very end like we've talked about with other types of problems. Now the inside tire, we again need to find the circumference because that's the distance that it would travel all the way around that one full turn. But now, if we're going to use the radius of this inside tire, we don't have that yet. We have to realize we have to do a little work to get that. What would be your radius for that inside tire? Okay, this radius would be 11.4 feet. You would find that by subtracting 16.1 and 4.7. So now again, leave this in terms of pi. I'd have 22.8 pi feet for the circumference of that inner tire's path. Now to find the difference between the two, to find out how much further the outer tire travels than the inner tire, we would just be subtracting. So take the distance of the outer tire, subtract the distance of the inside tire. So now when you subtract, what you have to realize is that the pi symbol does not go away. It's not canceled out. It's like a variable. If you took 3x and subtracted x, your answer wouldn't be 3. It would actually be 2x. The variable still stays there. So this symbol would act the same way right now. But now once we have just that simplified answer, we would go ahead and put this in our calculator using the pi button, and we would have 29.531 feet as the approximate difference between the two distances those tires travel. Now, arc length. Arc length is a fraction or a portion of that circumference of the circle. Arc length and arc measure are different. We have to understand that. We can find both of those for the same arc, but yesterday, or in the last video rather, we talked about arc measure is always measured in degrees. Arc length is measured in a typical length unit, a linear unit, like feet, inches, meters, miles, kilometers, whatever it might be. So the formula we are going to use for arc length is arc length equals theta over 360 times the circumference. And the big time key for this is that theta is the arc measure, which remember is the same thing as the measure of the central angle. So I can put theta out here as the measure of arc AB, and I can also show it in the central angle as the measure of that central angle. Now, congruent arcs are arcs that have the exact same measure and are in the same circle or in congruent circles. So the second part of that, in the same circle or in congruent circles, what that would guarantee is that the length would also be the same. The measure and the length would be the same for those arcs. Now, since we're dealing with circles and we have this pi symbol, which is an irrational number, meaning at some point you're going to have to round it, we have to talk about approximate versus exact answers. When I ask you for an exact answer, or another way of me saying that is to leave it in terms of pi, what this means is keep the pi symbol in the answer. Simplify all the numbers that you possibly can, but keep the pi symbol as a part of the answer. When I ask for an approximate answer, now is when you would use your calculator and type all your values in and use that pi button instead of leaving the pi symbol in the answer. So actually finding length of an arc. Here we're going to give our answer to the nearest thousandth. So I'm actually going to show you both the exact and the approximate answers, what they would look like. But the ultimate answer we'll give as the nearest thousandth. So in this circle, if I have to find the length of arc AB, I have to realize I have to start with the formula for length of an arc, which is theta over 360 times circumference. Now, if I look at my diagram, I know my central angle is 145 degrees. That's the same thing as the measure of the arc. And then 14.2 inches is my radius, so I can use that in the circumference portion of that equation. So notice I have the 145 in for theta, 14.2 in for the radius in what would be 2 pi r to help find circumference. So now, if I wanted to have just an exact answer for this, I would take the 145, the 2, and the 14.2, and I would multiply all those values together. Because 2 is over 1, 14.2 is over 1. I can take all the numerators and multiply them together, and then I would have my denominators multiplied together, so 360 times 1 across the bottoms as well. Pi would also go in the numerator, but you'll notice this has been reduced. If you take your calculator right now and you do 145 times 2 times 14.2, you'll notice it says something other than 2059, because you would have to reduce if you were to leave this as an exact answer. So hopefully you know how to use your calculator to help you work with fractions and then reduce fractions, keeping them as improper fractions. If you don't, make sure you talk to me and I can help you out. So this would be what your exact answer would look like if that's what you were asked to give. But since you were asked for the nearest thousandth, you would just type that in your calculator now and find that the length of AB, arc AB, excuse me, would be 35.936 inches. Now I'd like you to try to do B. Again, just worry about giving me the answer to the nearest thousandth. When we do part B, we have to start out with that same arc length formula again. 67 would go in for theta. The 30.8 would go in for radius if you're using 2 pi r for circumference. Now I am going to show you what this exact answer would look like again. I understand there's a decimal in the numerator, and at this point in the game, I'm going to be okay with that as long as it's not something that we had to round. So this would be what I would accept for your exact answer. I would also accept it if you wanted to use your calculator and make it so that there are no decimals within the fraction, and you could simplify it that way. But this would be okay for me as well. The answer that I asked you for, hopefully you gave me 36.017 meters. Again, don't forget about your labels. And notice these aren't square units, they're just linear because we're talking about a length, not an area. All right, another type of question that you might have to answer that is related to arc length is to find the circumference, of a circle. So here, if you notice in the diagram, we're given the length. We can tell it's the length because of the label. That's why labels are so important. If this were the measure, it would say 85 degrees. But since it was a centimeter label, regardless of the number, we know that's talking about the length of that arc. So if I start with my arc length formula again, now when I plug values in, I don't have anything to help me find the circumference. That's what I'm trying to actually solve for. So now you have to think, how would you get this C variable for circumference by itself? How would you solve for that? This fraction, what would you do? Hopefully you recall from algebra that to get rid of a fraction multiplied by a variable, you should be multiplying by its reciprocal. So if I multiply by the reciprocal on both sides, that gives me 4,320 over 85. Again, because the 12 is 12 over 1, and I'm taking numerators together and denominators together. And then, of course, you always have to simplify. And I didn't specify whether I wanted the exact answer or the approximate answer, so either one of these would be fine. You can leave it as 864 over 17 for the improper fraction, or you can give me 50.824 centimeters if you gave me a decimal. But again, both, or whichever one you decide to go with, would have to have a label of centimeters. The last thing we'll do, we have an athletic field here. Now this looks like a composition of shapes. It's an athletic field, I get that, but if you look at it, it's really rectangles and semicircles. So we're given the dimensions. I've given you a picture here that's also labeled already, so you may want to copy this onto your notes. Now we're told that the track is divided into 8 lanes of equal width, and our job is to find the distance around the track along the inside edge, and we're actually just going to stop at the first lane. We'll talk together about how you would find other lanes. So if you think about the lane or the distance around the inside of the first lane, it's actually this line that is the border between kind of the tan and the green sections of this picture. I want to find that total length. So it's really made up of different parts. But regardless of which lane you're running in, your lane or along the inside edge of that lane, there's 2 turns and there's 2 straightaways that would have to be combined, actually added, to find that total distance. So let's break all of this down a little bit. The first turn, how long is it? The second turn, how long is it? What are they together then? And then how long are the 2 straightaways? Well, each turn in this, it says, is a semicircle. So we'd have to find circumference and then take half of it. So each of those would be 1/2 times circumference. But they are the same because when you have this track, those semicircles would be the exact same. Since the lengths of the rectangular field are the same, the radius of each semicircle would be the same, so they would be congruent to each other. So 2 turns together, if I add the 2 half circumferences or if I double it, the total for just those 2 turns is the circumference of just 1 circle. Now each straightaway we were given as 100 yards. So now when we actually want to calculate the distance around the inside edge of that first lane, we would just take the circumference of that circle, if we could combine those 2 semicircles to make 1, and we would add 200. So we would have pi times diameter for the circumference, and then add the 200. The diameter is 40 yards. So if we use our calculator to plug all that in, round to the nearest thousandth, we'd find that that distance is 325.664 yards.